Hi everyone, welcome to Netgate Chemistry. So this is going to be the last video of solid state. In the previous video we studied about Bragg's diffraction, Weiss indices and Miller indices. So today we are going to study the structure factor. Before going into the definition or the formula of structure factor, we should know what is form factor. It is represented by small f and the formula is amplitude of radiation scattered by one atom divided by the amplitude of radiation scattered by one electron. This is the formula for your form factor. Next, we should know total scattering amplitude. It is represented by capital F and the formula is amplitude of radiation scattered by one unit cell divided by amplitude of radiation scattered by one electron. Now the formula for structure factor is first structure factor is represented by capital S and the formula is capital F upon small f. Now there is also a formula for intensity. Which is equals to F square, capital F square. Now there is a condition for allowed or forbidden reflection, that is, if S is equals to 0, then the reflections are forbidden. And if S is not equals to 0, then the reflections are allowed. So now we are going to study about the properties of your Miller indices and your intercepts. So first property is that intercept can never be equal to 0 and your Miller indices can never be equal to infinity. Because there was the case of intercept where intercept was going to be infinity, in that case we used Miller indices because that was the limitation of your intercept or your Weiss indices. So now when we are dealing with Miller indices, they cannot be infinity. Second property is that intercept could be infinity and Miller indices could be 0. Third property is that Miller indices cannot be fractional and your intercepts or your Weiss indices can be fractional. So now what do I mean by saying this third property? Let's say I have a question in which after solving a given intercept or Weiss indices, I have got Miller indices as 1, 3/2 and 1/2. Then I cannot represent Miller indices like this because Miller indices cannot be in fractions. So what I'm going to do, I will change them into integers. How? Take the LCM of the denominators. The LCM comes out to be 2. Now multiply each of the terms with 2. Okay, take the LCM and multiply each of these terms with that LCM. So what we are going to get? So now these are your Miller indices. Okay. Again, one more question. If after solving particular Weiss indices or intercepts, I am getting Miller indices as 1, 1/3, 1/2, then I have to further solve it to get my Miller indices. That is, I have to remove these fractions and change them into integers. So what I'm going to do is take the LCM of the denominator. The LCM comes out to be 6. Now multiply that LCM with each of the following terms. So these are your Miller indices. Okay, so with this, solid state is over. Thank you so much for watching.